Alrighty, friends, yesterday was so much fun with geometric sequences that we're just going to continue on and learn more. All right, so yesterday we learned that a geometric sequence has successive terms that have a common ratio, which means you are going term to term by multiplication or potentially division. So if I have 2, I multiply it by 3 and get 6, multiply it by 3 and get 18. So as I go along, my common ratio is 3 in that case. Okay. So this means that every term is multiplied by the same number. So even if it looks like division, like if I had 18, then 6, and then 2, here what you are doing each time is, yes, mathematically you are dividing by 3, but that's not your R value. Your R value would be 1/3 because each term is 1/3 of the previous. And I would multiply 18 by 1/3 to get 6, and I would multiply 6 by 1/3 and so on. So that multiplication piece is important to kind of keep in mind. So let's take a look at this general form. Like the more you can get a handle on what these pieces mean, the easier it will be for you to kind of get what you're doing. Think of this as like your ending term where you're trying to get to. Think of this as the term that you're starting with. And then, so you're gonna like start here and you're trying to get to some G sub n term down the road. Well, to get there, you're going to be multiplying by R, by R, by R repeatedly. And that's why R times itself, and so on ends up with a power. So this is going to be my common ratio. And the common ratio is always going to be raised to a power. And that power, the total power there, you're going to notice is the difference between these two. And so essentially by doing that, you're figuring out like how many times am I using R? So you're looking for like the space between your start and finish term. So let's take a look at how that's going to play out, because understanding that, you're just saying how many times should I repeat the R to get where I am going. So if I have, it says find the equation, so it wants us to write it in that general form of the geometric sequence, and then it gives you G3 and it gives you R. Okay, so I'm going to be looking at writing G sub n, meaning, hey, you can get to any term you want if you start with G sub k, which has to be like your starting term, and we have to start at the term we know, so I'm going to have -3 in that spot. They're telling me the R is 10, so I'm multiplying by 10, then by 10, then by 10, and the number of times is going to be how far it is from this third term to the nth term, so the difference between them. And I don't know what n is, so I use that in general and then -3, because that is the k value that I had, because that was the subscript of the starting term, and I had to start at what I knew. And then now I have a general formula, so I could find the 5th term by plugging in a 5. I could find the 10th term by plugging in a 10, and so on. So let's dig in a little bit deeper. Always using that formula. I'm going to end here. I'm going to start here. I'm going to use this ratio however many times it takes to get from k to n, the difference between them. So as you read this, it says you know G sub 2. You know your common ratio, so you're going to find the expression, that's going to be this, and then use the expression to find G sub 5. That is going to be a secondary step. So you're going to first find the rule, and then later you're going to plug in n equals 5. But first you have to get what you're trying to, like your general equation. So my general equation is going to be like, hey, to get any term down the road, start with G sub 2, because that's what we were given, using your ratio like n minus 2 times, because that's going to be the difference. So let's plug in what we know. We were given that G sub 2 is 24, so we're starting at 24. We are applying our ratio of 1/2 n minus 2 times, and that is where we stop. That is our formula. Okay, then if they want me to find out what would be the 5th term, G sub 5, I simply take that formula and I put in a power of, an n value of 5. So keep in mind that 5 minus 2 would ultimately result in a power of 3, which would turn into 24 times 1 over 8 if I took a half times a half times a half. So the fifth number in that list or sequence is going to be 24 times 1/8, or 24 divided by 8, or 3. So there's two different phases to that. Try it again. Let G be geometric. So it's telling you, and obviously we're going to have problems where they're mixed together, so you do have to pay attention. It's giving you G sub 3 and your R value. It wants you to find the expression using that general formula and then use it to do G7. So this one is going to be the same as the previous process. My general formula, I'm going to start with what they gave me, which was G sub 3. I'm going to start with the ratio they gave me, and the difference between these two is going to be n minus 3. But they gave me a starting value of 2. So I'm starting at 2, a ratio of 3 to the n minus 3 power. Because I don't know the space between n and 3 because I don't know what n is. Okay, now that I have my expression, that's what they're asking me for here, I'm going to go ahead and do what it says, which is find G sub 7. I'm going to take my formula that I just created and I'm putting in a 7. So it's not like rocket science. If you have an n down here in the formula and up here in the formula, they have to be the same number when you go to do your work. So again, PEMDAS is kind of real and we want to do that power first. So I'm going to have 3 to the 4th power, and then that's going to turn into 2 times 81. And then my 7th term in that list would turn out to be 162. And you're going to have to do some of these without your calculator, so keep in mind that you're going to have to do some mental math or jot some things down. So this is kind of the new level. It says time to level up. And then this is a new concept for us right here, is how do we do this? These first ones are quite honestly examples from yesterday. So if you're given any two terms, you do not know the R. So what you're doing here is you are finding that common ratio without a list of numbers, without two neighbor numbers where you could just divide them. The words here are kind of confusing, but we'll go through the problems together to figure it out. So it's telling you to use both terms, the one that you know, to create one equation in general form. It says use the larger value as the G sub n term. So basically it says use the larger value as like your ending. So that's going to be your G sub n. Okay, solve. So you're going to use the equation that you created, and that is going to help you find R. So now you know the common ratio, and using that value along with either term, that's key thing to know, is it doesn't really matter which one you choose because you're finding an R value that works for the entire thing. So it doesn't matter which term you choose to use as your starting. Then you can write a general form equation. Okay, so I know how to do this. So looking at that, I'm like, oh yeah, that makes sense. But I feel like it doesn't make sense. So let's try it together. So they're telling you it's geometric. Super important to pay attention to that because sometimes it'll say arithmetic and then your approach is different. They're giving you a third term and the sixth term, and it wants us to find the expression. But in this case, we need R. So that's going to take an extra layer of solving to get it. Once we get it, we're going to go back and just plug in 11 for the n value. But we need an equation first. And before we do that, we need to find R. So there's several steps to what we are going to do. So the first thing I'm going to do is I'm going to first find R. So this is from up above. And it says to use both. So in ending, I'm going to do the term that would be further down the list as my ending term. and the one that would be closer to the beginning as my beginning term. So I'm saying, hey, I'm going to start at the third term and go to the sixth, and I'm going to use my common ratio however far that is. And from the third term to the sixth term will ultimately turn out to be 3 steps. So I go back to what they told me. This is going to be 128. Then the third term is -2, which I wrote as like a really big bad Z. I do not know the R, but I do know that 6 minus 3 is 3. So now I'm just going to solve like you would have back in algebra. So there's my first step. That's going to get me to -64 equals R cubed. And we are not going to panic because the cube root of a negative is just a negative. You can go ahead and take an odd root of a negative. So if I do that, I get -4 as my R value because -4 times itself a third time would land you at that -64. Okay, now we're going to move on to step 2 up there, or like our second step. We're going to find the expression. So again, we are back to saying, hey, we need to find a general expression. You can start with either of the numbers given. It says right up here, start with either term. Well, I am going to choose this guy. So I'm going to start at the third term, use my common ratio, n minus 3 times. What do I know in here? I know the third term is -2. I just learned the R is -4. And then I'm looking for just the general equation. So I'm done. And please, please, please do not eliminate those negatives. Don't decide in your brain that 2 negatives make a positive because PEMDAS is real and you would need to do this first. And that -4 might end up being negative if it has an odd power, and it would end up being positive if it has an even power. So you can't guarantee that it will cancel out with the -2. So just leave it. Okay, then step 3, whoopsies, don't write with a highlighter, kids. So step 3 says to use your expression to find G sub 11. Great, easy peasy. I'm gonna plug in an 11. Okay, would I have to do this without a calculator? 100% not. But when you do this on your calculator and in your brain, that exponential part's going to get done first. And because -4 is raised to an even power, it actually turns out to be positive. So when multiplied by a negative, your answer to that 11th term is -131,072. So I would say, that's a 7. I would say it would be smart of you to try this on your calculator and convince yourself that that is indeed the answer. My biggest fear is that you're just gonna be like, oh, those negatives cancel. And now you got a positive 131,000, which is like super duper different than a negative 131. Like if your bank account has positive 131,000, great. If it's negative 131,000, not so great. All right, so this is gonna give us a chance to practice some of this. Look at that, it's geometric. I know the second term and the 7th term. I'm going to need to find R. Once I find R, secondarily, I'll find an expression, and when I'm done with that, I'll plug it in. So we have 3 steps again. So let's find R. I'm going to say, hey, G sub 7, if I start at G sub 2, I'll use my R, 7 minus 2, which is 5 times, because that's how many steps are between the second and the 7th term. What is G7? 1.5. What is G2? 48. What is R? No idea. 7 minus 2, 5. Excellent. So now we need to solve that. So I'm going to divide by 48, divide out the 48, and I'm going to end up with 1 over 32 equals R to the 5th. So if you 5th root that, which on your calculator, you can type in, depending on kind of what kind of calculator you have, you could type in the 5. And then if you go to math, you should be able to see a root symbol like this. And so if you type in the 5, it'll put that in there. Now, depending on how old your calculator is, it may or may not display it in that index spot. but you've got to tell your calculator, I'm taking the fifth root of 1 over 32. And when you, when you do, you find out that R is 1/2. So first mission accomplished. And they don't tell you to find R, you just have to. Now I'm going to pick, I don't know, I guess I'm going to pick this because it just feels easier to use. So I'm going to say, hey, my general equation to get to any term, I'm going to start at my second term, use my R value, and this is, excuse me, since this was a sub 2, my power is going to be n minus 2. So this is going to be my overall general equation. And then I can use that for my step 4, which is to find g sub 11. So the 11th number would be what I get when I plug that in. So I'm going to have 48 to the 1/2 to the 9th power, except for, yes, sorry. And then that's going to end up giving me 3 over 32, or if you do it as a decimal, you'll have 0.09375. Same process, different numbers. Grand finale of fun. Gave me the third term and the 7th term, so I'm going to need to find R. Then I need an expression, then I'm finding a term. Same exact steps. 100% I think you should try this on your own and then watch the video to see if you did it correctly. All right, I'm going to do mine so that I end at G7 and I start at G3 because G7 is farther down the road. I'm going to use my R, 7 minus 3, which is obviously 4 times to get there. What do I know? I know G7 is 32. I know G3 is 1/8. I do not know R, and I know 7 minus 3 is 4. So to get from 1/8 to 32, I'm trying to figure out what number I would multiply by 4 times. So to solve for this, I'm actually going to multiply both sides by 8 to get rid of that. So then I'm going to have 256 equals R to the 4th. So I'll need to do the 4th root of that. And my R is going to be 4. Alrighty. Then I can write my general equation to get any term, and I'm going to pick, I guess this one, I'm going to pick G3 as a starting spot, 1/8, and then my R is 4, and if I'm at G3, this is going to be n minus 3. This is now my general formula. So last step, once I have that, to find G9 is easy. I just plug in a 9. So on my calculator, I'll end up doing this because clearly you don't have to do 4 to the 6th power on your own. And so I end up thinking, okay, the 9th term of this geometric sequence would be 512. So clearly the fact that I had to do this 3 times in a row means that these examples are something I should probably be pretty good at, where I have to figure out R. So make sure you spend some time on that practice and that you are able to go through that 3-step process because you're obviously going to have to. Alrighty, have fun. Bye.